This is chapter 17 for Bio 103, and we're going to talk about waste management here. We're going to talk about the types of waste we generate, waste disposal methods, ways to reduce waste, as well as industrial and hazardous waste management. Our case study is the mania for recycling on campus. In 2001, Ohio University and Miami University competed in a 10-week recycling event called Recyclomania. In 2014, 461 colleges competed for this. Recycling Mania is the biggest of a growing number of campus competitions in the name of sustainability. It's gaining lots of momentum, and colleges are also adapting other sustainable practices. So we define waste as anything we don't want anymore, anything we want to throw away, whether we call it trash or garbage or whatever. It's stuff we don't want anymore, and we produced it, but now we don't want it anymore, and we need to get rid of it. There are three main categories of waste. There's municipal solid waste, which is the stuff that's picked up from your home every week when the trash man comes by. Industrial solid waste is produced from the production of goods and any type of manufacturing or mining or agricultural process. And hazardous waste is in particular waste that can be solid or liquid and is toxic, chemically reactive, flammable, or corrosive. There are a number of ways in which we can manage waste. Simply source reduction is the preferred approach, which is to find ways to not generate the waste in the first place. We can recover and recycle waste materials as well, and find ways to reduce the overall material that has to be disposed of in what we call the waste stream. Most municipal solid waste is things like paper, trash, yard debris, food scraps, stuff like that. The biggest components are food scraps and plastics. A lot of it is packaging and non-durable goods, stuff that's thrown away after a very short period of time. Fun fact, the U.S. citizen generates an average 7.1 pounds per person each day, which has resulted in us being labeled as the throwaway society, although the waste we generate has decreased slightly between 2005 and 2012. Here are some pie charts showing the recycling material. This is the component of it before recycling. Here it is after recycling, the percentage of different materials like paper and food waste and plastic and metals and other stuff, glass and things like that. Developing nations are producing more waste these days. Consumption patterns are increasing with the rising standards of living there, which means wealthy consumers often discard items that can still be used. The poor people in many of these countries often scavenge local dumps looking for things that they can sell and try to support themselves. Wealthier nations invest in waste collection and disposal to minimize the impact on health and the environment. In 2012, 35% of waste in the United States was either recycled or composted. The most common way to dispose of waste is in what are known as sanitary landfills. These are regulated under the Federal Resource Conservation and Recovery Act. All U.S. landfills must meet those standards set by that, and they must obtain a permit from the state agency. Sanitary landfill is simply burying the waste underground in a way that tries to isolate it from the environment and then allow the waste to be partly decomposed by bacteria and break it down over time. So here we have a cross-section of a typical landfill. The idea is to have a series of layers between the waste and the groundwater, so it minimizes groundwater contamination. So they'll have a plastic and a gravel layer, a compacted clay all to contain it, and each day's waste is covered in soil, so it ends up looking like a bunch of cells containing the waste. There's also what's known as the leachate collection system. This is to collect water that flows through the waste stream here. As water percolates through the waste, it may pick up hazardous materials, paints, and other stuff that's in the waste, and so that's a potential source of groundwater contamination. So the leachate collection system collects that material and then treats that water to separate out the hazardous stuff. These collection systems must be maintained for 30 years after the landfill is closed. There are drawbacks to landfills. Liners can be punctured and leak. Leachate collection systems that aren't properly maintained can still contaminate the groundwater. And it takes decades or longer for the waste to decay. Another problem with landfills is what's known as the NIMBY syndrome, which stands for not in my backyard. Residents don't want landfills near their homes. They want the waste to be taken far, far away from where they live. So people with wealth and other political clout can prevent landfills in their neighborhood, which results in them being disproportionately sited in poor and minority communities. Landfills can be transformed after closure. They've been converted into public parks and gardens, wetlands, even festival event. An alternative to sending it straight to the landfill is what's known as incineration, which is controlled burning of the garbage. Metals can be removed during incineration, and then those metals can be recycled. The remaining ash then is often loaded up with toxic materials and must be disposed of in a hazardous waste landfill. So incineration doesn't really eliminate the need for landfills, but it does reduce the volume of the garbage by up to 90%, so it can cause us to need fewer landfills. And of course, because you're burning something, there are air pollution problems associated with incinerators, and they need to be dealt with through pollution control technology. This includes the use of scrubbers. As we mentioned in Chapter 13, scrubbers use a chemical spray to remove air pollutants, and also must capture what's known as the fly ash, which is particulate matter that can be very toxic. And these are often captured by those baghouse filters. So here's a typical waste-to-energy incinerator. The trash comes in and is dumped into what's known as the tipping floor. It goes into the pit. Then dropped by a crane into the furnace where it is incinerated. The bottom ash is collected here. The toxic materials travel up and goes through the scrubber and the bag house to capture the fly ash, and then they go into the landfill. And of course, because you're generating a lot of heat, these are called waste-to-energy incinerators because that heat can be used to boil water and run a steam turbine to generate electricity. So waste-to-energy facilities then uses the heat by waste combustion to generate electricity. We can also get some energy from landfills. As the trash decomposes, it will produce methane gas. That methane gas can be collected and used just as if it was natural gas. Reducing waste is a good option for managing waste. Source reduction is simply preventing the waste being generated in the first place. It avoids the cost of disposal and recycling, helps conserve resources, reduces pollution, and can save money. A lot of waste consists of materials used to package goods, so using minimal or recyclable packaging. If you look at things like CDs, if they are still being sold, and everything hasn't gone over to MP3s, the size of the packaging in these things have gone down considerably since CDs were first introduced in the 1980s. A lot of other materials and consumer goods use a lot less packaging than they did 20 or 30 years ago. Also, choosing products that are more long-lasting can reduce a lot of the waste generated. Some local governments are trying to reduce or even ban plastic bags, encouraging people to use cloth bags because plastics can take centuries to decompose. They can choke and entangle wildlife, and there are 100 billion of them that are discarded every year in the United States. So some places have simply banned them altogether. Others have put a tax on them to reduce the use of them. So here at Table 7.1 is some actions that can be taken to reduce the generation of waste, including donating things like clothing to charity, buying bulk groceries, buying reusable cloth bags, double-sided photocopies, rechargeable batteries, use your own coffee cup at the coffee shop, and so on. Composting is the conversion of organic waste into a mulch or humus that can be used as a fertilizer for soil. People can compost their food waste and their yard waste in their homes and then use that and their gardens for fertilizer there. College campuses are encouraging composting in places like Ball State University in Indiana and Ithaca College in New York. Municipal programs can also encourage composting, where the municipalities will collect food and yard waste maybe separately and then convert those into a mulch and give those back to the neighbors and the residents for use in their homes. About half of U.S. states now ban yard waste from the municipal waste stream. Recycling is taking waste materials and then converting them into new consumer products. There are 3 steps to it. First is collection and processing of the recycled material. This can be done through curbside recycling or dropping them off at designated recycling locations. These locations that then collect the material, whether it's delivered to them by the garbage trucks or people bring it to themselves, are called materials recovery facilities, or MRFs for short. Step 2 is using the recyclables to produce new goods. Things that can be recycled into new goods include glass, plastic, paper, plastics, metals, and other materials. Step 3 is consumers buy the products made of recycled materials. There are 9,000 recycling programs that serve about half of Americans in this country. Recycling rates vary tremendously around the United States. It often depends on state and local policies. Businesses can often see that they can save money through recycling, and entrepreneurs can start new businesses. Here are some examples of materials that are recycled in the United States. The percentage of the material that is recycled or composted. For example, lead acid batteries, often used in automobiles. About 96% of the recycled. It's mainly because most landfills will not take those things. So when you get a new battery put in your car, the garage almost always recycles the old ones. About 70% of newspapers are being recycled, at least among people who still buy newspapers these days. You see other things, a little bit more than half of aluminum cans are being recycled and so on. Plastics, only about 9% is recycled. That's pretty poor. Recycling has grown rapidly over the past couple of decades. Recycling has grown rapidly, particularly in college campuses. The recycle mania practices and trash audits that have been done to reduce the amount of trash being generated in many places. Recycling has also grown because municipalities want to reduce waste, public satisfaction, and support for recycling. Recycling may not always be profitable. It often depends on the material and the current prices that it can be sold at. There have been times when recycled newspaper has been very profitable. Other times it hasn't been. I know copper recycling is very profitable to the point where there's actually a problem of people breaking into construction sites and stealing the copper tubing and selling that to recycling centers. Researchers at Sensible City Lab at MIT have placed tracking devices in various kinds of trash in New York City and Seattle to try to track where trash goes, to see where it ends up. What they found is hazardous waste items, electronic waste items tended to travel furthest because they were sent to special facilities for handling. This raises the question as whether this special handling is worthwhile, given the global warming impact of the fuel consumption used to transport the material. But this tracking data can help us find ways to improve the ways in which we handle waste. Businesses are starting to look at salvaging materials for landfills that can be recycled, including many metals and other wastes. Harvesting methane from open dumps in Asia and Africa has been looked at. But cost and regulatory requirements have made investments in what's known as landfill mining risky. But this may be the future, especially as many resources become more scarce and we have to look harder for mineral resources. There are financial incentives to help address the waste stream issue. There's the pay-as-you-throw approach, where residents are charged according to how much trash they put out. Places like Carlisle here in central Pennsylvania charge people by the bag how much trash. Instead of charging a flat monthly or quarterly fee to haul the trash away, they charge you based on how many bags of trash you put out on the curb each week. Bottle bills, in which consumers can collect a refund for returning a used bottle, They are often effective and popular in the states that have them, and they can reduce container litter significantly. Industrial solid waste comes from factories, mining, agriculture, and other industrial processes. It's not considered municipal or hazardous waste. The United States industry generates 7.6 billion tons of this material. Most of it is wastewater, which is then pre-treated before it goes to wastewater treatment plants. While the federal government has regulations for municipal solid waste, state and local governments with federal guidance do most of the regulation for industrial solid waste. Most methods and strategy for waste disposal, including things like source reduction and recycling, are similar to municipal solid waste. But industries may not be required to have permits or to install liners or leachate collection system for industrial waste generation. In many ways, throwing stuff away is just cheaper than to avoid generating the waste. If the market can be made more efficient, businesses will gain incentives to reduce the amount of waste they generate. Industrial ecology is trying to find ways to reduce the amount of industrial waste generated. This involves redesigning systems to reduce the waste generated, or finding ways to make us value-added products out of the waste product. This can involve what's known as life cycle analysis, where you look at the life cycle of a product, find where waste is being generated, and find how waste can either be avoided or maybe utilize that waste in another way. So businesses find that they can save money while reducing waste in many of these life cycle analyses. Interface, a carpet tile company, asks customers to return used tiles for recycling and reuse. And this has cut waste generation by 80%, fossil fuel use by 45%, and water use by 70%. And has saved them about $30 million a year. The Swiss Zero Emissions Research and Initiative Program helps businesses try to find ways to convert their waste into goods and services. So in this example, we're looking at a brewery here. And the old way is the brewery used grain and water to produce beer, and it generates spent grain and wastewater as the waste product. And they just often sold the spent grain as animal feed, and the wastewater, though, was just waste that was costing them money to dispose of. So what the Zero program did was look at this and said, hey, let's take the spent grain, use some of that to make bread, and now we can sell bread as well. Use some of it also to generate a substrate for mushrooms. There's another product we can sell. And then use the spent substrate for animal feed for pigs. We can also use the wastewater, since that's high in nutrients, and give that to the pigs as well. Of course, then you have the issue of, well, the pigs generate waste, so what do we do with the pig waste? Well, we take that to a digester, use that to produce biogas, yet another product that we can sell, and also use it as a fertilizer for algae for growing fish in fish ponds. So you end up creating many more consumer products, including bread, mushrooms, pork, biogas, fish that can be sold in the market. So it gives you an expanding list of products your business produces while generating less overall waste. There are 4 categories of hazardous waste, and many types of hazardous waste can belong to 1, 2, 3, or even all 4 of these categories. And these categories include ignitable. These are things that easily catch on fire, such as natural gas and alcohol. Corrosive materials, or anything that can corrode storage tank or equipment, so strong acids or bases are corrosive. Reactive or chemically unstable materials, these could be explosive, or those that could produce noxious fumes when they react with other materials. And then there's the 4th category is toxic, and these are materials that are harmful to human health when we inhale, ingest, or touch them. Industry generates a lot of hazardous waste, but the waste generation and disposal of hazardous industrial waste is highly regulated by state and federal laws. Households also generate lots of hazardous waste that is largely unregulated. These include a lot of things like paints and batteries and solvents and cleaners that people use in their homes. As we talked about in an earlier chapter, many hazardous substances can degrade and become less hazardous over time, but others, including heavy metals, many organic compounds, and even radioactive waste, can be very persistent over time. Hazardous materials can include synthetic organic compounds that are resistant to decomposition. These can include plastics and tires, pesticides, solvents, preservatives. These are often resistant to decay and what makes them persistent. It's also one of the reasons why they're often used. Many of them are toxic. Many of them are mutagens, carcinogens, teratogens, or endocrine disruptors. Heavy metals can also be hazardous. Lead, chromium, mercury, arsenic, cadmium, tin, and copper. These are used widely in industry for wiring, electronics, metal plating, pigments, and dyes. Many of these are fat soluble and can bioaccumulate and biomagnify in the food stream. E-waste, as we mentioned in Chapter 11, often contains large amounts of hazardous materials. We discard about 300 million devices per year, 3/4 of which still work. They are put in landfills but should be treated as hazardous waste. Many of them have valuable materials that can be recovered. The 2010 Olympic medals were made from e-waste. They're actually made from recycled electronics. E-waste generation is increasing tremendously as more and more electronic devices enter the market. They end up entering the waste stream eventually. Disposing of hazardous waste can vary from location to location, especially when we're talking about household hazardous waste. Many communities designate certain days or sites where household hazardous waste can be disposed of. Other places don't really have any regulations at all for the disposal of household hazardous waste. Under the Resource Conservation Recovery Act, or RCRA, the EPA sets standards for the disposal of hazardous waste, but these regulations are managed by the states. Large generators of hazardous waste must obtain permits, which includes tracking the material from what's known as cradle to grave, where the material is generated, tracked all the way to where it is disposed of. And this is supposed to prevent illegal dumping. Hazardous waste is very costly, which often gives businesses incentives to engage in illegal dumping. So industrial nations sometimes illegally dump in developing nations, even though this is banned by the Basel Convention. The high cost encourages companies to invest in reducing their hazardous waste, however. Landfills are one way to dispose of hazardous waste, but they don't reduce the hazards themselves. If the hazardous waste landfills leak, the hazardous materials can eventually enter the groundwater and contaminate the drinking water supply. Hazardous waste landfills are engineered and designed to be more protective of the environment. They have stricter standards in place than ordinary sanitary landfills. They often have several impervious layers and a double leachate removal system, and they have to be located far from aquifers. Surface impoundments, which we mentioned in Chapter 11, are often temporary ways to deal with hazardous waste. These, again, are shallow depressions that are lined with plastic and clay. A liquid or slurry is poured into them, allowing the water to evaporate. Residue that is full of hazardous waste is then transported somewhere else for disposal. Of course, concerns with these is that the clay layer can crack and leak, or rainstorms can cause them to overflow and contaminate areas. Deep well injection is a permanent disposal method where you drill far deep underground and find a porous layer of rock where you can inject hazardous material in it. The well needs to be isolated from the groundwater and not anywhere near where humans can get at it and be exposed to it. Concerns with deep well injection, though, is sometimes the wells can corrode and leak, and the hazardous material could eventually enter the groundwater that way. To deal with contaminated sites, particularly lots of former military and industrial sites that were contaminated through past practices, Congress passed in 1980 the Comprehensive Environmental Response, Compensation, and Liability Act, or CERCLA, sometimes also referred to as the Superfund Act. This establishes a federal program to clean up old contaminated sites that are polluted with hazardous waste. The EPA is also required to clean up brownfields under the Superfund law. These are land areas where reuse or development is complicated by leftover hazardous materials from previous industrial activities. Two events really spurred the creation of the Superfund legislation. One was Love Canal, and this is near Niagara Falls, New York. In 1978 1980s, family were evacuated from the area after buried chemicals leached through the surface and started bubbling up on the surface and seeped into people's homes. The other was Times Beach in Missouri. This town was evacuated after the area was contaminated with dioxin from oil sprayed onto the roads. The Superfund process starts like this. Once a contaminated site is identified, the EPA put it on a priorities list and they start taking note of whether the material is confined or likely to spread, how close is it to people, whether it has an immediate threat to drinking water supplies. Harmful sites then are placed on what's known as the National Priorities List, which is ranked based on their level of risk to human health. And then the EPA puts it out to bid, where contractors are hired to clean it up. And then the EPA must hold a series of public hearings to inform residents of its findings and get feedback from the residents about how well they're doing to clean it up. CERCLA operates under what's known as the polluter pays principle. One of the things they do is they send lawyers out to identify who was responsible for the contamination at the site. And then they try to drag them to court and get them to pay the cost for cleanup. However, when responsible parties can't be found, the costs come out of this trust fund, this super fund that was established. Now, originally the super fund was paid for by a special tax on the chemical industry. However, that tax was eventually allowed to lapse, and Congress did not restore it, so now funding for cleanup comes straight out of the general funds that taxpayers pay. As a result of this shift in how things are being done to pay for it, fewer cleanups are being completed than in the past. There are about 1,300 sites remaining. Only about 375 have been cleaned up in recent years. Each one costs about $25 million and can take up to 15 years. And that brings us to the end of Chapter 17. So we've talked about waste management problems, ways in which we can reduce waste generation, recycling and reuse, and the best ways to deal with our different types of waste.